All right, so let's continue with the second part of our review, where we get to practice with two pyramids and then find the surface area of a couple of circle solids. We are not going to do the PAV questions, although I expect a lot of you to be able to do them. I'm just not going to go over them. And so we have just 4 questions left, starting with these two pyramids. To find the surface area of a pyramid, our formula is 1/2 perimeter of the base times slant height plus area of the base. And that is true for all pyramids. 1/2 perimeter of the base times slant height plus area of the base. So in our first pyramid, our base is a square. And so let's go ahead and find the perimeter of our square. To find the perimeter of any shape, perimeter means you need to add up all the sides of that shape. And so our square has 4 sides. So we're going to add 12 plus 12 plus 12 plus 12. We should understand that repeated addition is just multiplication. So I can take 12 and multiply it times the 4 sides in my square and get that the perimeter of my square is 48 centimeters. Now, 9.1 is referring to the height of the prism, how tall the prism is from apex to base. Right now, we do not know the length of our slant height. We will need to use Pythagorean theorem to find it. But I do have all the tools that I need to find the area of the base, the area of this square. To find the area of a square, we're going to do length times width. Where the length of my square is 12 and the width of my square is 12. So the area of my square is 144 square centimeters. And so I'm going to go ahead and pull out my right triangle. We did this in our notes on the first day of pyramids, where we let 9.1 be our tall leg. What we are looking for, this triangle, you can say it's backwards or it can look like this. So I'm referring to slant height there. But this triangle would be the same measurement no matter which way you pointed it inside your pyramid. And so this is the same as that triangle. I just have it facing this traditional way. And so if this leg is referring to how long that is, or how long this is, or how long that is, it's going from the center of my circle out. And so all the way across my square, not circle, is 12. So if we go from the center out, this short leg is going to be 6 centimeters long. And what we need to find is the slant height, or the hypotenuse. And so Pythagorean theorem, 6 squared plus 9.1 squared equals slant height squared. In the calculator, I'm going to type 6 squared plus 9.1 squared. I'm going to type exactly what I see here. And the calculator is going to tell me that this side of my equation is 118.81 is our slant height squared. We don't want our slant height squared, we just want to know how long the slant height is. So to unsquare it, we're going to take the square root. And we find that our slant height is 10.9 centimeters. 10.9 centimeters. One half 48 times slant height 10.9 plus 144. Again, I'm going to type this in my calculator exactly the way I see it. and I find that the surface area of this square pyramid is 405.6. If our problem had asked for the lateral area, we would just do this and we would leave this out. On your test tomorrow, there will be a couple of problems that ask for lateral area. So, we always approach these problems by identifying what shape is our base. And so our base is a triangle. In fact, we should be able to see that it is a equilateral triangle. And so all the sides of my triangle are 8 meters long. And I'm going to redraw that equilateral triangle down here in just a moment. So we need to find the perimeter of that equilateral triangle. We need to see if we have the slant height of our pyramid. And capital B stands for area of the base, so area of our equilateral triangle. And we should know by now that to find the area of a triangle, that's 1/2 base times height. So let's find the perimeter first. We're going to add 8 plus 8 plus 8. Or if we understand that repeated addition is multiplication, I can take 8 and multiply it times the 3 sides and get that our perimeter is 24 meters. In this problem, we don't have to use Pythagorean theorem to find the slant height because our slant height is given. And our slant height is 11.2 meters. And so, looking at this triangle on the bottom, there's no height that is given. There's not a height that's given. And so we have to find the height. And while it might seem like finding the height is a job for Pythagorean theorem, this is actually going to be a special rights problem. All the sides are 8, but I'm going to move this 8 over to the hypotenuse. And focus on this 30, 60, 90 right triangle that's inside my equilateral triangle. How do we know that's a 30, 60, 90? Well, we should just know about equilateral triangles that each angle is 60. So if this angle is 60 and I come in and drop down a right angle, that only leaves the only option here to be 30. So half of my side is 4. And we don't know the height of our right triangle or the height of our equilateral triangle. They're the same thing. And so I'm going to opt to divide and multiply out for this problem. Our rules for 30, 60, 90 are 1, 2, and radical 3. If I take my 4 and divide it by 1, I get 4 for my box. If I take 4 inside the box and multiply it times the rule on the side that I need, 4 times radical 3, we find that the height of our base is 4 radical 3. And so I'm going to use 4 radical 3 whenever I find the area of my base, because it's the height. 1/2. Now if I look at this triangle, that is my base, the base of my pyramid. The base of the triangle, it's 8. So I'm going to put 8 right here. The height of the triangle, we just did a lot of hard work to find, is 4 radical 3. And I'm going to leave this in simplified radical form. So what I'm going to put in my calculator is 1/2 8 times 4. meaning I'm going to multiply everything except for the radical. And so I find that the area of my triangle is 16 radical 3 square meters. I have 3 pieces. It's time to plug them into my formula. 1/2. Our parameter is 24. Our slant height was given and it's 11.2. And the area of the base is 16 radical 3. And this goes in the calculator exactly the way we see it. And I find that the surface area of this triangular pyramid is 162.11 square meters. Now, with our circle solids, they have their own special formulas. And so to find the surface area of a cone, we do pi r L plus pi r squared. Pi, our radius is 9. Our slant height we don't know, plus pi 9 squared. And so this right triangle is going to help us find our slant height. So on that right triangle, the radius is 9, the height is 14, and we have to find the slant height. Pythagorean theorem will tell us that 9 squared plus 14 squared equals our slant height squared. Take the square root of both sides. We get that our slant height is 16.64. Since it looks like a decimal is unavoidable in this problem, I am not going to leave this problem in terms of pi, because there's already a decimal that's kind of made that not pretty. And so I'm just going to type in the whole thing exactly the way I see it. Pi r L plus pi r squared. And I find that the surface area of this cone is 724.95 square inches. So, almost last, one more. We're going to find the surface area of this sphere. The formula that we just got yesterday for a sphere is 4 pi radius squared. 4 pi, if our diameter is 22, that means our radius is 11. 11 squared. I'm not given a decimal, so if I type all this in and pi is 3.14159, I'm going to get a decimal. And since I'm not given a decimal, I'm not going to give a decimal. And so we're going to leave this in terms of pi. 4 pi times 121. And 121 times 4, we find that we have 484 pi square millimeters. Our last shape that we're going to find the surface area of. With surface area, we have to think we are covering the shape. What we are going to do is find the surface area of not just half the sphere, but we want to cover this circle right here as well. So our surface area, we need half the sphere, so half of 4 pi r squared, plus the circle on the bottom. How do we find the area? Because all this that we've been doing is finding area, just area on the surface. So how do we find the area of a circle? We're going to add in pi r squared. You might be able to simplify this. Half of 4 is 2. 2 pi r squared plus pi r squared. Oh, it looks like we have 2 of these. This and this is the same. So if I go ahead and combine that one more time, the formula that's going to get us the total surface area of this shape is going to be 3 pi r squared. 3 pi, our radius is 6.5 squared. Since they give me a decimal, I feel comfortable giving a decimal. Although I will check and see if 6.5 multiplies times 6.5 squared multiplies times 3 and makes a pretty number. It doesn't. So I'm just going to type it in the way I see it. 3 pi 6.5 squared. And I get 398.20 square centimeters. So this concludes our review. If you'd like to try out these problems, you may. And your test is definitely going to be about 10 questions. You're going to have some surface area of prisms, surface area of pyramids, surface area of cones, surface area of cylinders, surface area of spheres, and you will have a couple of lateral area problems. And so that will be your test. Y'all, I'm honestly probably going to make your test out of questions, the same questions that you've had for practice. So if you have not finished either of your practices, now is the time to do that, now that you've completed your review. So